Alrighty. Welcome to Community Office Hours. This is a Consul KubeCon special, and we're going to have a deep dive of multi-cluster service mesh today. So that's going to be pretty fun. We've been hearing a little bit of chatter on the KubeCon Slack about it, so I'm really excited. We'll see a little bit of that today. I'm Rosemary Wang, a developer advocate at HashiCorp. And we're here with David, who is a product manager of Consul and Kubernetes and various ecosystems. Also, please correct me if I'm wrong on that one, David.
Consul on Kubernetes, and yes, other types of Kubernetes distributions.
Awesome. So if you have any questions or comments, please put them in the chat. We love questions, we love comments, and if we don't know how to answer them, we're going to find someone who knows how to answer them. We also have Blake and Cody on the chat as well. So again, if neither David nor myself know how to answer them live, we'll probably defer to Blake and Cody. So we'd love for you to interact with us. We really enjoy it and we love hearing what you have to say, but please keep in mind our code of conduct in this virtual space. In general, be welcoming, inclusive, friendly, and patient. Be considerate, be respectful, and be professional. You can review our code of conduct at hashicorp.com/community-guidelines. With that, let's get started. David, I hear you have a demo for us.
Yes, I do. Let me really quickly give you folks a really quick overview of Consul and Consul on Kubernetes before I dive into that, and then I'll show you guys show you folks a demo. So just 1 second while I share my screen. And wanted to talk about what Consul is. So for folks that have not used Consul before, Consul is a distributed system platform, and it provides some basic things if you were to deploy your own distributed system, whether it be on Kubernetes or whether it be on a virtual machine. And we originally started with the project around service registry and health monitoring, so you can see what services are inside of a catalog, so to speak, which ones are available that we can hit, and what is the actual IP address we can hit based on a domain name, since IP addresses can change a lot. Since then, we've focused on two different areas that are strategic to us. One is the network middleware automation story. So the whole path around making sure that various network devices that are spun up in your enterprise or within your environment can be configured quickly and easily using tooling like Consul, and also connected in a straightforward manner, are things that we're trying to solve in the problem areas that we're looking at. We also have started to invest heavily inside of building a service mesh that works for large enterprises, as well as folks that are trying out service mesh for the first time. And we built this with security in mind, and also made it really easy to get started. So you can start to leverage not only just the service mesh technology, but also things that we built before, built in the Consul, like the registry and health monitoring. So we built Consul originally as a binary that we distributed that you could download, install on a virtual machine. But what happened was, over time, folks wanted to start to also deploy this on Kubernetes. And Kubernetes definitely changed the deployment architecture, and also, how we thought of the distributed system would look like. And so we built our basically a way to deploy that. And we have a project called Consul Kubernetes that I'm part of, and we basically have a really quick and easy way to get started on building a full Consul cluster using Kubernetes. And folks that have used this, if they've never tried Consul, this is most likely one of the first places people start. And so essentially what it does is you can set up a full cluster with basically your servers that actually keep state of the distributed system, and have other things that are stored in terms of state to keep track of things like who can talk to what and what permissions people have. And also we also have the ability to deploy the clients, which are basically in the case of Kubernetes, the worker nodes, right? So we can deploy clients onto the worker nodes, and then we can use an API to talk to it, to talk to the service mesh or the catalog. In this diagram here, so what we're seeing is at the very bottom, we have the servers, and we also have clients deployed across all the nodes. So servers are basically, again, the thing that maintains the state of the cluster. Now, clients are basically our way into Consul, and it exposes an API to talk to. The servers themselves, they communicate via gossip as well as the clients, so we can know the state of the cluster at any time. We deploy the servers as stateful sets inside of Kubernetes, and we also deploy the clients as a daemon set, so it actually deploys across the entire cluster. Using this architecture, we're able to basically achieve building a Consul cluster from the ground up in a really easy way, and we have a mechanism to do that with Helm. The other thing that I will say is that Consul is meant to connect a lot of different platforms together. We talked about service discovery and service registry, but in the context of service mesh, we can start to leverage Consul to talk to different clusters and different network segments, if you will, isolated networks. So we have a way to do that, and this is the main purpose of this talk is to talk about multi-cluster. And we built that with that in mind. So let me go into the next slides, and just really quickly, I'm just going to show you some basics on a Consul Kubernetes, and then I'll dive into a demo. And while some of the demo is spinning up, I'll come back to slides to talk about some internals. So if you've never used Consul, we actually have a Helm repo to get started, and this not only includes the Consul chart, but also includes the Vault chart as well. And you can basically come up with your own set of values based on a Helm reference, decide what kind of version of Consul you want to deploy in there. We usually default to the latest one that's available as GA, and then you could set options that make sense for you to deploy and go ahead and install it. And that's what I'll show you how to do. I'm going to show you to do that in two different data centers real quick, and then I'll talk about actually WAN federation. But before I do that, let me show you what I'm trying to accomplish, just so you can see this diagram. So we built a concept called the mesh gateway, and that mesh gateway is basically a way we can actually communicate between two different service meshes. In the top diagram here, you see this is just one service mesh, but at the top diagram here, we can see there's basically something called a data center 1, which is its own network, and then we have data center 2, which is its own network. And so let's say we have a service in one data center that wants to talk to the service in another data center. How do you accomplish that? And also, how do you make this this distributed system understand, like, what servers are available and who can I talk to? And we use mesh gateways to basically accomplish that, which is in charge of doing things like making sure that the gossip communication is happening appropriately across the different networks, and also the RPC that happens between the servers themselves. And so essentially in this demo, I'm going to stand this up on top of Kubernetes, and I'm going to show you a really simple service that has one specific application running that then talks to another one. And I'll enforce zero trust by making sure that we actually have what's called an intention to authorize that communication from one data center to another.
So before you switch
so what I'll do,
before you switch off that slide,
yep.
A couple of questions, because we've been hearing a little bit about this in some of the commentary going in the KubeCon Slack. So someone was mentioning that they were actually using this approach to kind of migrate services from VMs into Kubernetes. When we talk about Consul data or a data center in this diagram, what does that exactly mean? Is that like a Kubernetes cluster? Is that a Kubernetes cluster with a bunch of VMs? What does the construct of a Consul data center mean?
Yeah, so we think of data centers as separate isolated networks, physical or virtual. So let's talk about it in the cloud context. When we think of data center, I would think of it as separate regions within cloud service providers. So like, let's say, US West 2 versus US East 2. Those are two different regions, two different networks we need to communicate. In the case of VMs and Kubernetes, that's also the case, where a virtual machine is running in its own separate network, and then you have a Kubernetes cluster running in another, and that's typically what I've seen. Obviously, if they are able to talk to each other, they can be part of the same data center. Like if they're in the same, LAN network and they have IP routability from the kube cluster to the VM, that's definitely possible. But typically, what we've seen is in virtual machines in Kubernetes is they're typically in separate networks. And what you would do is you have this mesh gateway. Let's say DC1 is where the VMs live, and DC2 is where Kubernetes live. You basically stand up a set of Consul servers and clients that represent that VM cluster, and Consul clients and servers run the kube cluster. Use that mesh gateway to federate between the two to get that traffic going through. And that way, eventually over time, if your goal is to get onto Kubernetes completely, you can use this pattern to slowly migrate those virtual machines, those workloads on virtual machines onto the kube cluster. And then maybe at a certain point, you wouldn't need the mesh gateway. Maybe you still do because you have another region that you want to talk to. But that's essentially one pattern that mesh gateways falls really well into.
And another question we had was, what is the way that the mesh gateways communicate with each other? So for example, if one data center is in a DMZ or a very restricted network, what is sort of how do those mesh gateways work together? How do you make sure that the two data centers can actually federate?
Yeah, so a mesh gateway, the two mesh gateways need to have network connectivity. So there has to be like some kind of public IP on both ends and a specific port that's exposed that allows it to communicate from one to the next. In this case, like we would encrypt the traffic from one data center, and then we send all that traffic, whether it's the gossip traffic or the RPC traffic, send it through the mesh gateway while it's encrypted. And then on the other end, we decrypt it and then communicate to the actual mesh itself. Or send that layer through the mesh and then decrypt it at the clients. So it does require that they have network connectivity. You can probably set up different types of things that are allowed to do that within a cloud provider or within a physical data center. The ones that I think of on top of my head in cloud service providers are things like transit gateways, or you would do things like VPC peering, where you make sure that one VPC can talk to another. So those are the things that you would typically do to make sure they can talk to each other. And you would only have to make sure that one entry and exit point are available, not a bunch of them.
Yeah. So someone was asking about OpenShift projects, and I know did the Consul Helm chart recently get OpenShift support, I think?
Yeah, that's a great question. So we definitely have heard a lot of feedback on this, especially since OpenShift is one of those distributions that has heavily benefited from the Kubernetes community. The Red Hat, obviously the Red Hat folks have contributed heavily towards Kubernetes, and they've built a lot of the constructs that get borrowed into Kubernetes themselves. And we wanted to support that model, especially on the enterprise. And so we did release a version of Helm that now supports deploying Consul on Kubernetes on top of the OpenShift platform. We are now able to basically, let's say you create an OpenShift project, within there you can actually go ahead and deploy Consul on Kubernetes, and then you can also make sure that the workloads you deploy in OpenShift get registered and sidecars and get injected appropriately based on the right security context constraints, and then you can then start to work securely inside of an OpenShift platform.
So is it fair to say that one project would almost be equivalent to one Consul data center? So when you do this deployment, does it give you the Consul in one data center, or are there options for you to have multiple OpenShift projects associated to one Consul data center?
Yeah, so you would basically want to, if you were to operate an OpenShift cluster, you'd probably want to start with a single Consul cluster, and that's typically the model that we suggest, is have a single Consul cluster per Kubernetes cluster. And what you can do is you can then split that cluster up from a Consul perspective using a feature called namespaces that gives you a better way to manage. Okay, this namespace for my team works with these specific, pods and deployments, make sure that they have access to a console namespace, which is the same kind of concept, and they work within that domain where they have their own authorization to do certain things inside a console. So you would want to typically deploy only one cluster within a Kubernetes cluster.
That's all the questions we have for now. So I think we can demo.
Cool. Awesome. So hopefully, if you look at my terminal, you can see my screen. So what I'm going to do
bump
is
up the font like
heavily, yes.
Heavily. I know some people are watching on their mobile devices. I'm so sorry. We're going to try our best to bump it up as much as possible. I'm watching on a larger screen, so if you could bump
bigger.
Yeah.
Even more.
Even more. Maybe like the trials and tribulations. Oh, perfect. Okay.
All right.
Yep.
Okay, hopefully that's a little better. Cool. Oops. Let me put that. Give me a second. Oh no. Let me reshare something real quick. Okay. I lost this one. Okay, cool. So what I'm going to quickly do, so this is a kube cluster. There should be nothing on here. Right. What I'm going to do is really quickly go ahead and deploy Consul on one cluster and then the other one on the other, and go through that specific demo. The purpose of this, it might take some time to spin some of these things up, but is to show you how easy this is. So what we have now is we have this, I've spilled up the config. Oops. So yeah, I don't know if I can, okay, here we go. So this is my config for the first data center, and this basically is going to spin up a Consul cluster. We're going to enable something called federation. And also we have this nice little trick where we can actually create what's called a federation secret automatically. That allows us to take, how do we talk to one cluster and another cluster and transmit it on the other clusters so that they can authenticate and talk to each other. I'm using ACLs. ACLs is a system that basically allows us to manage what permissions people have in terms of APIs. You can definitely turn this off, but in practice, for security purposes, you want to turn that on. And also, there's the connect inject option here at the bottom. Is how we enable the service mesh, and the mesh gateway is the actual thing that gets deployed if you enable that as well. So what I'm going to do is I'm going to run quickly a Helm install. Before I do that, I'm going to go ahead and generate what's called a gossip key. So one of the things that we do in Consul is we have gossip communication that happens between each other, but we also want to make sure that the traffic between them is actually securely encrypted. Something like this, we created the secret inside of Kubernetes. I used a kubectl command. You have a Consul CLI command called Consul key gen that allows you to do that. But using this, I can actually go ahead and create the actual Kubernetes secret. And so what I'll do next is go ahead and actually install Consul itself. And we talked about that Helm Valleys file. And so I'm just going to go ahead and use that same file and go ahead and quickly deploy this. And so what it's going to do, again, is it's going to deploy the servers, it's going to deploy the clients, it's going to initialize TLS to make sure I have TLS set up appropriately. And then as part of the whole process, also going to generate that federation secret. And then eventually you should see them all spin up, and then you'll see the actual token then used to actually go ahead and communicate across that.
So this is like a confusing thing that I hear a lot about, which is gossip encryption. And just to make sure that this is clear, gossip encryption is encrypting the communication between client and server, correct?
Right. Yeah. Making sure that the communication that happens, right, between the nodes to make sure that we understand the state of the world is encrypted. But it's not like the RPC communication that happens, like when you make a call from one service to another. It's more about making sure that the internal state of the cluster is well understood.
And the TLS configuration in the Helm chart, is that TLS configuration for the service mesh components? Is that, or like for any of the proxies for MTLS? Is that TLS for even client server communications, client proxy communications?
Yeah, so if I dive into the details of TLS, we definitely have a section on here in terms of the Helm config that talks about that. There's various different things that we enable now. I'm not using all the TLS methods, but we have things that we definitely want to make sure that TLS is enabled to make sure that it's something that we do and enforce. But we have some other fields in here that are useful in certain cases, right? Enable auto encrypt, for example, is a feature we built recently that makes sure that we can bootstrap Consul, make sure that certs are regenerated if they expire appropriately using the Consul API. We do have other things in here that allow us to also bootstrap these TLS, like CA certs and CA keys. And you can use that natively within Kubernetes. But typically when you deploy Consul to get started, you want to just enable TLS. And then if you do some fancier things like federation, you would enable this, CA cert and CA key. And then if you do things like, hey, I want to deploy my servers external to Consul, I would use some of these things here called server additional IP SANs and DNS SANs. So I just deployed, sorry, I gotta make sure you guys can see this. I just deployed Consul, and you can see right now I've got my mesh gateway set up, I've got the servers set up, I got the clients set up, and then if I do secrets, I know it's kind of hard to see, but you can see that the Consul Federation secret here has also been generated. And so what I'm going to do next is actually export that secret. So typically what you would do is, I already have generated one, but I'm going to use a newly generated one and then switch over to the other kube cluster. But typically you would take that and you use something like, what is it? A vault to store the actual secret itself securely and then also distribute it. I'm going to go to the next cluster. Oh. Okay, and okay, I don't have anything there. So what I'm going to do is I'm going to go ahead and first actually use that secret that I generated and create it so that the cluster has it. So you can obviously get that, you know, via Vault as well if you wanted to, but just to make sure we have it, let's see, this Consul Federation secret is now in there. And then the next thing I'm going to do is show you the actual data center 2 values, which we're actually deploying Consul in the second data center. And so if you look at this, it looks pretty similar to the last one. But here, what we're actually going to do is leverage some of the TLS options that are now exposed to us via that Federation secret. The Federation secret has a lot of things in there, and we actually mounted as basically as a volume inside of our pod, and we can actually pull out different configs in there. But once we mount it as a volume, now what we're going to do is leverage the CA cert and CA key, and then use that as a user replication token as well to make sure the ACL is replicated. So let me run this real quickly and run install on DC2. And install that. So while this is running, I'm going to go really quickly over what is actually in that federation secret. So the way you would actually, I'm following what the docs say here.
Could you pump
But if
up
you look at,
the screen font on the browser too?
yeah,
Thank you.
I forget you can't read the browser as well. But what I'm actually doing is I'm grabbing the federation secret that's generated in the first data center that we actually started to deploy on, and then what it I'm actually going to imply that. So what's in a federation secret? So let me find the actual. So inside of a federation secret, we have a multiple different content. So we have, it's basically, if you think of it, it's the secret itself. If I just do a cat on, if I do a cat, federation secret, right? You can see this is the actual, if I scroll up, we actually have a couple things in there. We have the CA cert. This is just encrypted in base 64. We have a CA key, gossip key, replication token, and server config, right? So what is all that? And so what we're trying to do is on DC2, we're trying to understand what is that certificate authority that the first one uses so we can communicate across each other? What is the key that's used for encrypting that traffic? And then also, what's the configuration, right? So the configuration allows me to set what is my primary data center, my secondary data center for Consul. We have this concept of primary and secondary, making sure that one is the first one that is stood up, and also the master of inside of a federation zone, all the data centers themselves. So we want to make sure that that's set up appropriately, and we understood that. And then we have a token that's used to actually replicate our access control list to understand who can access what. And also that that same gossip key that I generate at the very beginning, I don't have to create this in data center 2. I'm just using the first one. And so once I create this in the second cluster and I run through helm install, we're just going to use all that. And then if I go, let's see if I see my pods here. See here, it's basically not all running, and I got my mesh gateway set up, and I have some of a federation between the two clusters. Now, what I want to do is basically just make sure that each cluster understands that we have the other servers based with on the local IP address, that it's part of the actual federation. So, and I just ran a Consul members Wang command. So in the first, this is DC2, I can see the other DC1 members that are now part of this federation. I can do the same thing, right, on DC1, and then run the same thing there and see that. So making sure that they're now connected as part of the federation. Next, what I want to do is actually deploy a workload. So I'm going to do this. I'm going to do this in 2 steps. I'm going to deploy a workload on DC2 and then a workload on DC1. And I'll first show you that by default, they won't be able to communicate with each other. So let's do that. So I'm going to switch over to DC2. And I have this thing called a static server. Static server. Right, so basically, if you look at this, just basically a pod that runs HTTP echo and then listens on a specific port, and actually just going to deploy that onto DC2. And so let's do that. And then I'm just going to really quickly see if it's actually just running. See, it's spinning up. Eventually we should see 3 of those pop up. Yep. And then I'm going to go over to DC1, make sure there's nothing deployed there, and then also deploy another workload, which is basically the client. And so I'll show you the client. Here. And so we're using annotations here, right, to inject sidecars in this case, as we typically do when we deploy pod. And then here you can see this is my client, which is basically curl, and it's just looping, right, every 30 seconds to talk to this static server on DC2. And you can see that in the upstreams like section here, I actually defined like this is my server's name, and this is my port that I'm trying to hit, and then this is my data center that I want to hit as well. And so I'll go ahead and, oops, I don't know why I copied and pasted that, but I'll go ahead and run kubectl apply on the client, right? Make sure that that's all up and running and good. And we should see that slowly spin up to 3 once they pull the images and then deploy the actual containers and then the pods. And once that's done, I'm actually going to go and switch over to the UI inside of one of the data centers. Okay, so one of the things that's nice about Consul is, we have all these things already built all together, right? So before I show you the UI, I just wanted to validate one really quick workflow. So I'm going to emulate actually talking from the client to the server. And so what you're seeing here is basically, we can't talk to it. There's no network connectivity from the client to the server. So I'm getting the exit code on curl. And so what I want to do is show you how to set up this communication path. And I need basically what's called a bootstrap token first to log in securely inside of my UI. And I'm going to use port forward to basically open up the actual browser or the open up the connection to the actual UI. So let me go ahead and go here.
You could bump up this screen too.
And
I
here we
don't
go.
think,
Yes.
unfortunately, tabs don't seem to preserve zoom, the zoom in, which is very disappointing.
Oh yeah, that's right. So I'm going to log in using my ACL token. So when you generate like a new console, when you bootstrap ACLs, you get this token, and this token is basically your master token. And right now I'm acting as an administrator, and you can create additional tokens, right, to delegate permissions, but I'm acting as an administrator console logging in. And then what I want to do is, you see I have nothing here. I don't have any what's called intentions. I'm actually going to create an intention inside of the UI. So what I'm going to do is, there's a service listed here called static client, right? That's exactly what I just deployed. And then what I'm going to do is I'm going to want to make sure we have an intention set up to talk to static server. Oops. And make sure we allow that. And I'm going to save this real quickly. So you got this this intention set up to make sure the client can talk to the server. And then this is my actual service, and you can click on it to see all that stuff you want to see, like what node is deployed on, health, and etc. of that. So if I go back and do the same thing, I'm just going to kill this real quick. What my demo should show is now with this intention, I should get a hello world. And that shows basic federation, making sure that one service and one data center can now talk to another service and another data center, and we make sure that this communication can happen. So in a nutshell, in about 10 or 15 minutes, I showed you how quickly it is to spin up like a federated service mesh across multiple kube clusters. and also showed you how to actually make sure that traffic isn't forced to flow from one to the next, using examples here that I've shown. So I wanted to now turn this over to some other things I wanted to talk about, just to give you some other context. We do have a pretty vibrant community, and multi-service mesh is something that we definitely care about, but we also have obviously other things that we want to hear from you. And so one of the things I wanted to point you folks to, if you have additional questions and general troubleshooting, we have what's called Discuss. This is a forum where you can go and ask us questions, and office hours is something that we do, and we post in here to talk about that. We also post what we've just released in Consul as well. We also have another way to reach out to us for more advanced topics where people are requesting things that are not there. Let's say using this multi-mesh configuration, and there is a specific feature that's not there that you're looking for, and you wanted to make sure that we're aware of that. We do have a way to collect that information through issues and PRs. We're fortunate enough that we get PRs from folks that are trying this out, making changes on their own. They also provide feedback in a different project called Consul K8s, where we actually store our Golang binary that runs as a container and is deployed through Consul Helm. And so we have different ways to interact with the community here, and this is something that we heavily appreciate. The feedback that we get, and also the different ideas that we see out there from the community. And these are some other information that I went through like really quickly. Obviously, there's a tutorial version of this. There's also docs, and this is the other links here. But hopefully, you found some of this helpful. I know in some cases this can be a pretty complex topic, but I want to make sure it's consumable and digestible in this format, and hopefully you found and learned something new.
Thanks, David. All right, if you have questions, continue to post them in the chat. We actually have one question about federation. How does this flow change when federating Consul from a public cloud to on-prem? Is this a supported deployment path from HashiCorp?
Yeah, so if you are going to, so if I understand the question correctly, you want to go from public cloud to on-prem. That's definitely possible. Obviously, first of all, you have to make sure that connectivity is there. We've seen folks that they need to have a cloud provider maybe provide a construct that enables that, right? Like an express route, for example. And what you would utilize that to basically make sure that your data center on your physical data center can have access to your cloud provider network, or your VPC there, and making sure that connectivity is there, and we can make sure that the mesh gateway is deployed on both sides. And if there is network connectivity, as we talked about, between one and the other, that is possible. You would have to also make sure on your end that you secure that pathway via other types of constructs. I know we've seen different partners that have different solutions that can enable that.
Yeah, it's there are a couple different methods. Highly recommend. Cody's in the chat, but highly recommend any of the demos Cody's run. He's got a good setup that'll show you how to do it. But on top of that, it's possible to do. If you, oh, sorry, David, if you could remove screen share, that way we can go back to gallery mode. Thanks. If you are, it is possible, even without the mesh gateways and everything else. It was a possibility to do it, for example, with AWS and on-prem. There's a demo I did of that at reInvent, and it was actually pretty seamless. As long as you're running Consul Discovery in your data center, in your on-prem data center, you could effectively synchronize the catalogs. Now, it wasn't the most elegant operator experience, and I think the federation experience now has really improved that capability, and it abstracts that workflow significantly now. So I think it really has made it much easier to be able to federate between on-prem and public cloud. All right.
We also have a section in our docs. When you look at Federation, that explicitly talks about how to do that VM and Kubernetes Federation. So I highly recommend you take a look at that. But yes, we definitely want to make sure that that path is viable, and also happy to hear more feedback from the community as well.
There actually is another question about Federation. And this one I think it's a trickier one, but how do I change my primary data center? So let's say I set my primary data center when I was federating, and now I change my mind, I want a different primary. How would I change that?
Yeah, that is a tricky one. To be quite honest with you, I don't think we found the right answer for this right now. We're definitely in research mode. We've heard people talk about this. We do have ways to do some things like disaster recovery if that's what you're shooting for. Basically being able to stand up the same data center in a different location. We have something to do that for Kubernetes. But actually physically changing like a secondary to a primary and promoting that is something that we have to think through, and also start to make some architectural changes to enable that. These are like large architectural topics, I think, that we'll continue to pursue as we start to go more into day two. Yeah, if you have that ask, happy to reach out. You can reach out to me at du@HashiCorp, and happy to chat more about that. Yeah, that's a challenging one for us.
Yeah, it's an open issue. So any feedback sent to David, and as Tobias pointed out, there's an open issue for it as well in GitHub. All right, so I've heard a lot of things this week. Specifically, I've heard a lot about operators and Kubernetes operators specifically this week. And, you know, with Consul, first question, does Consul have an operator? But the second question is, can you talk about CRDs and Consul CRDs?
Yeah. So first question, no. But let me answer this in a better way. What we decided was the SDK that the operator framework uses is actually pretty good for also creating CRDs, and we use that as our base framework, which definitely opens up the door to things like building up operators. But one of the things that we want to focus on with operators is understanding the use cases around how they can be utilized. The operator for the sake of building an operator is probably not the best thing, right? So is there something within like the management experience of Consul that we can improve upon through an operator-like functionality using Golang as opposed to writing a bunch of Helm hooks, right? We've actually thought about that, and there are definitely option possibilities. We also want to hear more from the community as well. We've heard things like, hey, like I want to also update my clients automatically, and can an operator do that? And those are some valid use cases. And there are ways we can get to that point. We will research this in the short term. We want to make sure that we have a path forward. But yes, I think there are some use cases that make sense. But an operator just for the sake of saying, hey, like I don't want to manage this thing, I just want to run, I think is probably not our strategy, because at the end of the day, like even in Kubernetes, there are things you have to manage, like in any distributed system. And there will be some times where you have to do this by hand. And we want to also make sure that that workflow is enabled, and that you don't have to go and like write Golang just so that you can actually manage something, if that makes sense, right? So that's kind of the philosophy that we're going with. But yeah, we have heard some requests around operators, and have seen other products also incorporate operators. I think maybe in the future we'll get there, but we definitely want to focus on like how does that improve our experience with Consul.
Yeah, and for those who are not as familiar with the Consul CRDs, recently you can now define custom resources, sort of Consul specific custom resources like service resolvers, service defaults, what are the other ones? Router?
Yeah, service splitter, yeah, router. And what we're doing is, previously what happened was when you're setting up the mesh, and you want to talk about how do you actually go ahead and allow communication to flow from one service to another, like what mechanisms you have to to route it correctly within the mesh. This is layer 7 routing, and we built constructs in Consul core, the actual binary that you deploy in virtual machines, for example, to enable that, and you would use the Consul CLI to actually enable those configurations via HCL. What we found, though, is over time, when we have to redeploy Consul Kubernetes via Helm, is that people don't want to always exec and then, basically apply those HCL files. And, that's not fun. Right? So we wanted to make it really easy, and we went forward to start to enable CRDs. And we think that's definitely the best UX experience for folks that use Kubernetes. And one of the nice things, and we have other features building into our 1.9 version, but one of the nice things that we also enabled is being able to define an intention via CRD. Is something that you weren't able to do before. You can do that, and you can also leverage, layer 7 attributes like headers and what paths are you hitting to make sure that enforcement on that traffic is enabled. So some exciting things happening there, and we're looking forward to more CRDs as well for Consul and Kubernetes.
Yeah, it's really neat. It's exciting because it as you pointed out, it's not the most elegant or efficient workflow to deploy your application, and then you're now, let's say you want to cut over traffic between version 1 and version 2, right? You would probably want to do that preferably with a Kubernetes YAML and some kind of traffic management formulation. And doing that with HCL was not exactly efficient. So now if I say I want to deploy, you're laughing, but it's true. I value my efficiency. I don't know about everybody else, but now if you do want to do traffic management, you can just say, here, let me give Kubernetes a YAML and tell Consul, let's split, version 1, version 2, or even better, you can basically cut traffic off to version 2 for a while, right? Using intentions, and say like, don't go to version 2. No one's allowed to touch it yet. It's not ready. We know it's not ready. And then you can basically use network policy to enforce that. So it's pretty exciting. I'm actually really excited about the intentions personally, because then I had to remember, if you have like a set, like an n tier number of microservices, I had to remember which ones go to which ones. I was like, this database has to connect to this one, which has to connect to this one, it was not fun. So I'm pretty excited about the intentions in particular.
Yeah, that's all YAML. You can just kubectl apply f. You're done.
Yeah, that's awesome. All right. Any other questions? Feel free to drop. We're coming up kind of on, within the next 10 minutes or so. So if you have questions, feel free to drop us a line. Any commentary, we'd love to hear about that. I'm trying to look at our list of questions here. But David, is there anything that you think is, you should watch out for when you're using Consul Service Mesh on Kubernetes in sort of the next year? Like, what do you think the conversation will be like? What do you think the team will sort of be looking at from a workflow standpoint?
Yeah, I think what we're looking towards is making sure that the Kubernetes experience is first class, and also making sure that this multi-mesh capability is exactly what folks are looking to do in their workflow. The single service mesh use case is something that we've been able to do for quite some time, for more than 2 years, but enabling this workflow for not just my own Kubernetes cluster, but also for other Kubernetes clusters, when you have them all talking to each other, what does that look like? The other things that we'll continue to see are things like tighter integration with Vault. Vault is a great platform for you to actually start to manage secrets, and there's even more capabilities that we have, but making sure that that zero trust is enforced all the way down to the CA and all the mechanisms that Vault has to generate and distribute certificates and keys and secrets. We'll continue down that path and making sure that the integration story is tight. Over time, you'll notice like our platform at HashiCorp is also evolving, and we have different now products that also adapt to different practitioners. Waypoint just came out and you can actually start to use, like for example, Nomad and Kubernetes and any other type of orchestrator also with the tools that we provide, right? On top of that, and we can expose that. And so we want to make sure that our platform works across our different tool sets. And although we don't want to lock you in, we want to make sure that what you get out of the tools is first class and the integration is first class when you start to experience that.
Awesome. We have a question that was originally posted in Kubernetes Slack channel, KubeCon Slack channel. Irina offered sort of a quick answer, which was there was a talk at Service Mesh Con that covered this. That would be a good resource. But the question originally was, what is a good place to go to learn, from here, Consul Service Mesh, to learn more about Kubernetes in terms of machine learning workloads and API servers? Have you come across anyone with a use case for that? Is that something that you think that Consul or even a Service Mesh could address?
Yeah, I think there are use cases. I just haven't heard of a lot of them off the top of my head. I think anything that involves a microservices architecture is fair game, where we can actually have one set of services that need to talk to another and making sure that they can communicate. I think as people start to build applications that are more complex, they're going to start to leverage that microservice strategy and making sure that, like, let's say I build another version of my AI platform that I want to start to split traffic to V2. How do I enable that workflow and making sure that whoever needs to talk to V2 also has that permission to do so? And so Consul enables you to do that. Right, via the service mesh technology, and also helps expose that if you have something like a service catalog. So I'm open to hear more projects like that. There are other types of projects that also are like, let's say, like job runners that you can probably deploy inside of Kubernetes, right, as Kubernetes jobs, and then or daemon sets, and they would just run. And you could possibly connect like one part of it using Consul. I'm not so sure if that's the best use case because it's such a large monolith. In some cases, they have different types of ports that are exposed, and they have different mechanisms in there. But I think over time we'll consider those use cases as well. But yes, I'm excited to see what the community thinks of, and also what people that want to use Consul want to do with it.
Yeah. I mean, I think what's fascinating to me is that I see a use case not necessarily for machine learning, but to control the flow of data, right? Because models need data and to actually be effective. And so if you're running something like Kubeflow on Kubernetes, or you're running some kind of machine learning workloads, I don't know, at least for me, the mesh piece or Consul's service mesh capabilities would be very good for controlling the flow of data, as you pointed out, which is, go to version 1, version 2, but not just version 1, version 2. Let me divide production versus dev traffic, or let me divert a small portion of production traffic to replay against this model. I don't know if that's possible. Maybe that's what L7 intentions are for, maybe more intentions, or even some additional capability in Envoy that, Consul will eventually pass on to Envoy. But that's where I see at least where the learning is. I don't know if it's necessarily machine learning on service mesh with the service mesh exactly, as much as just how you control the data flow going to these models, where it's being scheduled, how it's being processed, and how you're actually gaining visibility into it, because you do want to know where your data is going.
Yeah, anything that has like a client server model, I think is fair game for service mesh, and I think there are patterns that apply to that in machine learning. And there's also just patterns in machine learning where it's just like a constant job that just processes like a chunk of data and then puts into a database, for example. But yeah, I think use cases where client to server communication is appropriate, and making sure that when you deploy new versions of, like, let's say, a server, that you can split that traffic to it. Just experiment with that new version, see if it applies, and then stick with it moving forward. So that's where a service mesh can definitely help.
Yeah. If you have comments or questions, or you're using machine learning with a service mesh, curious to hear what your thoughts are. To be honest, I've never heard of a service mesh being used with machine learning. And today I've heard a couple of people ask about a Kubeflow on Kubeflow with HashiCorp tooling. So it's something that I will have to look more into. I think, let's see, if there's any other last minute commentary, please post in chat. Otherwise, thank you, David. Thank you so much for that demo of the multi-cluster federation. As David pointed out, there are a few learn tutorials on that. So do take a look. We posted some of the links in chat. We also have one more office hour. We have, I think, Derek tomorrow, and it will be monolith to microservices. It's Friday, November 20th at noon Eastern. We also have an episode of HashiCorp Live. We'll be live streaming the Terraform plugin SDK. So you'll get to hang out with Patty and Katie and Tracy, all of which who are fantastic plugin SDK folks. And you'll be able to kind of code with them tomorrow on Twitch. So both of those will be tomorrow, specifically tomorrow Eastern time afternoon. And with that, we're going to wrap this up tonight. I hope you had a fantastic KubeCon, and I appreciate, David, for you coming on here and showing us a little bit about Federation.